Now we have already defined functions. Then now we can treat functions as if it were numbers, such that we can add, subtract, multiply, divide, considering the domain. Okay, so let's go for algebra of functions. That means we will take two or more than two functions, we'll add them, subtract them, multiply, and divide. Let's suppose f and g be real valued functions. Okay, suppose these two are functions which are real valued. That means the domain and range of those functions are real numbers. By sum, I would mean f plus or minus g. Okay, if we have this kind of situation, if we want to add two functions and get a new function out of these two old functions, then you can simply add or subtract the expression inside these functions as if we were doing simple algebra. Okay, and also after getting this new function out of either addition or subtraction, you should be aware of the domain and range of the function. Number two is product. If you want to find the product of two functions, then it is written in this notation. Then we can simply multiply the expression of these two functions. Okay, and you can just think these two as algebraic expression and multiply them, and later on you can decide what is the domain and what is the range of this given function, this function that you have come up with. Finally, the third one is the quotient, or the division of two functions, one function by another, f divided by g. Right, if you want to find this kind of function, then you just go for numerator function to be f of x and denominator to be g of x. The denominator must not be 0. At least there should be one x, one number, such that this gx is non-zero. So gx must not be 0. So this is algebra of function, and we can use this idea of algebra of function, adding, subtraction, multiplication, division, to get new functions out of old. Let's take an example. Here we have two functions, f of x equals to x minus 1 and g of x equals to x squared minus 1. We want to subtract them, f minus x, f minus g, and we want to divide f by g. All right. So here what we need to realize is both of these functions are real valued functions. That means the domain of this function is the entire real number and the range is also the same. Here also domain of this quadratic function is entire real numbers, and range of this function would be -1 up to infinity, f minus g x. Okay, so we can write in this way, f of x minus g of x. Then go for a usual algebraic subtraction for these two functions, these two expressions, which is x minus 1, and this minus comes from the rule, okay, and g of x is x squared minus 1. So I can write this as x minus 1 minus x squared minus plus, minus times minus is plus 1. Okay. Alright, I multiplied both of these two things by negative 1. So this would be -1 and +1, they get cancelled. So x minus x squared is our new function that we got from subtracting g from f. Then you can easily understand that domain would be real numbers, and for range -infinity to 0. Now to find the quotient of f by g, we just go for f of x divided by g of x, right, equals f of x is x minus 1 and g of x is x squared minus 1. In the top we don't have anything to simplify, but in the bottom this is difference of a square, so I can write this as x plus 1, x minus 1. Okay. You can simply think that the domain of this function would be all the real numbers except -1 and +1, -1 and +1. Okay, so that would be our domain. All right, since we need to avoid 0 in the denominator, so that should be real numbers except -1 and +1. The function would be, now x minus 1 and x minus 1 can be cancelled out, so we will have x plus 1. 1 over x plus 1 would be the formula for the quotient. Okay. Now, don't get carried away by saying that the domain of this function is real numbers except -1, since we already know how we got 1 over x plus 1. So why this is the case is, since we have two common factors, x minus 1 on the top and bottom, and they can be cancelled out. Now, if you can cancel out the factors in top and bottom, then you say that there is a hole in the graph of the function. We say that in this case, if two factors are cancelled out, then we say that hole at, so there is a hole at x minus 1 equals to 0, which is x equals to 1. Okay, and tentatively, graph of this function would look something just like this. This is a transformation of the reciprocal function. Okay. X plus 1, it will give us -1. So let's suppose this is -1. Then our function would look like something just like this. It would be something just like this. Oh, sorry. It would be something just like this. Okay. It won't touch the line x equals to -1. And for x equals to 1, since we have a hole in here, so if you suppose this is 1, then you will have an empty circle in here. So that would be y equals to 1 over x plus 1. That's the graph, all right? So the range of the function would be all the real number except 0, and so if you have 1, then 1 over 1 plus 1 equals 1/2. 0 and 1/2 won't be there, okay, in the range. So this is 1/2. So I have avoided 0 and 1/2 from the range. So this is the discussion of how we can find new functions from the old and find their domain accordingly, domain and range accordingly.